I'm going to start by bringing. Well, I'm going to bring the scientist and the historian of science into the conversation, and I'm going to start with you, James. If you go out of this building by the red rope sculpture and look left slightly and ahead of you, there's a statue of Archimedes climbing out of his bath. And if you go under that, there's an archway. If you go a little bit further, a couple of gardens or quads further on, there's 5 small apple trees, which are supposedly taken from cuttings from the Cambridge apple tree that Newton sat under. It seems to the outside world and even to the scientists themselves that there's a love of this Eureka moment story. Historians of science have a slightly different view, don't they?
That's right, yeah. The orthodox position, insofar as we have any orthodox positions in the history of science, would be that Eureka moments simply don't exist at one level. I'll explain in a moment what I mean by that. If you do what we do, what we're paid to do, which is to go back and look at the documentary records, okay, so the most we can know about what the scientists were thinking and doing, if you go back to their notebooks, if you go back to diaries, correspondence, if you analyse the existing equipment as far as you can, you come to the conclusion, usually, that the thing that we see as the Eureka moment, the change, the shift away from one way of viewing the world to a very different one, is clearly there, but it's smeared out. It takes a long time. It might take months. Sometimes it might take more than a year. And, of course, the Eureka moment is supposedly it's a flash in the mind of an individual. Now, you will almost always find there isn't an individual. There is a group of people talking to each other, bouncing ideas off each other, collaborating, disagreeing violently with each other, refusing to accept each other's points of view. You will find, as a rule, that it's a very, very complicated, messy business. Okay, so at one level, if you look for the Eureka moment, it ain't there. And yet, people not only love, but need the Eureka moments. Certainly people who, as non-scientists, are trying to get an idea of what scientists do, or are looking for the impressive things in science, the things in science that they feel they should know about, but also scientists themselves. When they're reading into a new field, okay, you know, most scientists are very specialised. If they start working on something that's a bit outside their comfort zone, they have to have some sort of materials to hand to sort of brush themselves up on it very quickly. Or when they're starting out, when they're just students, when they're being taught science, they have to have some sort of picture that will help them to make sense of the science they've got now. And of course, like everybody else, they use history. History is a vitally important tool, which is why people like me are tolerated. But they use a form of history that is easy to understand to get the points into their heads. So you will use the Eureka moment, the discovery of oxygen, the re-theorization of the nature of electricity, the discovery of the theory of relativity, the atomic nature of the nucleus, or what have you, the discovery of DNA, of course. And these things, people... I say people, sometimes historians, sometimes the scientists themselves, very often the scientists, very often journalists and other people who have that kind of mediating role, they will take the smeared out mess of data and gather it all up and pack it, they will telescope it, they will push it in like pushing in a telescope, and they will construct a moment of change. So they take all the change that genuinely happened, be it over months or years, and they will take all the people in the story, edit most of them out, okay, which you have to do, okay? It's exactly the same if you're writing, I don't know, a political drama or something like that. There'll be thousands of people in the story. You take most of them out, you can't afford them, okay? It's noisy, it's messy, it's too complicated. You narrow it down, and you produce this beautiful, blinding moment of change, which is the Eureka moment. And so that's where it comes from. And people like me, a very small number of people, as I say, tolerated. The world reckons it can get on with having a few hundred people wandering around, messing all this up, basically, and saying, no, it was never like that. It could never have been like that. The world does not work like that. And yet, you've got, in order for science to keep functioning, in order for science to keep doing new stuff, you've got to have stories. You've got to have some sort of textbook story. And all the people like me can do, all I would plead for, is that we know and learn the difference between the two. Thank you.
just to bring Tim into this, that's one misunderstanding about science. I think you come up against quite a few. Do you want to talk a little bit about the sort of the biggest misconceptions of science that you deal with when sort of talking about it to young students or to the general public?
Yeah, I mean, there's a number of misconceptions, and I share many of them, I'm sure. But I'll just pick up on an example, actually, of the sort of thing that James was talking about there, and in fact links to what STELLA was saying as well about the universe and what Einstein did. Just to follow on from that, there's a sort of, you've probably heard of the Big Bang. Okay, what you may not be aware of is that the Big Bang sounds like a stupid name, and in fact it was designed to be a stupid name. It was the name was came up with by Fred Hoyle, who's a British astronomer who didn't believe in it. He thought it was a really rubbish idea. Surely the universe wouldn't have been in a Big Bang. That was his. It was to diminish the idea of the Big Bang. But that whole discovery that was what we think is actually how the universe came into being. The people that won a Nobel Prize for that were two guys called Arno Penzias and Robert Wilson, and they'd made an observation in the 1960s, and they found what was the sort of fading glow of the Big Bang. It was sort of radio waves that are passing through us all now. If you tune your TV set, if you can do that these days, usually digital TVs you can't tune very easily. Tune your FM radio or something in between channels, if you can do that these days. You'll hear static, you'll hear noise, and about 1% of that noise is actually radiation from the Big Bang. It's flooding through us all the time now. And they were the first people to find this. Now, they got a Nobel Prize for that. They're, rightly lauded for that discovery. But of course, it was much more complicated than that. And the story of that is entertaining in the sense that it began really with the story of how did the elements come to be? How did hydrogen, helium, carbon, nitrogen, where did the oxygen come from that we're breathing now? And there were sort of two warring factions, really. There was a group of people who thought that those elements would have been made in the Big Bang, or at the beginning of the universe, let's say, before the Big Bang name came up with. And there were people like George Gamow and Alpha and Hermann. And there was another group, people like Fred Hoyle and his collaborators, who believed that all the elements were made inside stars. And not because they didn't really like the idea of the Big Bang. And so they thought, okay, one group here trying to create all the elements in the Big Bang at the beginning of the universe, another group here trying to create all the elements inside stars. As it turned out, very quickly realised that because the universe was expanding, it was cooling rapidly, its density was going down, it wasn't possible to create all the elements in the Big Bang. So those guys sort of gave up on it in the 1940s. Whereas in the 1950s, Fred Hoyle and collaborators quickly realised that yes, you could create these heavy elements inside the stars. Every atom of oxygen you're breathing now was made inside a star. They came up with that successful idea, but they couldn't create the lightest elements. They couldn't create the hydrogen and the helium in stars. That had to have come, as it became apparent later, that was a sort of marriage of these two things. The light elements were made in the Big Bang, the heavy elements were made inside stars. But it took until the 1960s for these guys, Penzias and Wilson, who were doing something else entirely with the radio telescope in New Jersey, to find this very faint hiss, this underlying hiss that surrounds us all, that comes from everywhere, that was the fading glow of the Big Bang, that was the sort of, the smoking gun of the Big Bang that they found completely accidentally. Whereas a few miles down the road in Princeton, Bob Dickey and his collaborators had been feverishly working away on their theories, predicting that such radiation existed. They'd started to build the radio telescope that was going to find it, and then they heard that Penzias and Wilson had found it down the road, and Penzias and Wilson got the Nobel Prize. So I mean, that's a sort of, that's much more like what real science is, I guess, as a sort of story. It's much more messy and complicated. And I'm sure I've simplified that, in fact, from what the reality was. But that's sort of one level up on the basic idea.